Good day everyone. So in this class today we are going to cover the topics of chokes, action potential and resting membrane potential. So first the topic on chokes. So choke, what's the definition of choke? So chokes is nothing but it is an inductor. It is used to oppose the alternating current and it allows the direct current which is working on the principle of self-induction and Lenz's law to limit the alternating current with the minimal power loss. Okay, I will tell you what's the difference between the alternating current and the direct current. So alternating current is going to be in a reverse direction, and in direct current the current going to flow in only one direction. So the choke is the definition of the choke. It is going to allow the direct current and it is going to oppose the alternating current based on the principle of self-induction and Lenz's law to support the direct current to flow on to the circuit. Okay, so what is the construction of choke? Construction of chokes. So choke, it is insulated wire around a magnetic core. Okay, this insulated wire is made up of copper and inside a magnetic core that is laminated with the iron core. What is the use of this magnetic core? It is going to increase the inductance and efficiency of the coil, and this choke, it is in a cylindrical shape, and this choke coil, the coil of wire is insulated. Why it is insulated? It is because to prevent the short circuits. Yes. So what are the working of chokes? Choke in alternating current, what is the role of a choke is, it is going to be in a high inductive reactance, that is it is going to limit the alternating current with the minimal power loss. But in direct current there won't be any change in the current, there won't be any reactant inductance. It is simple, it is a simple wire, it is going to work on the basis of low resistance and it allows the direct current to pass on throughout the circuit. And then this choke, it is used for many purposes. So first one, it is used for the filtering, it is used for the smoothing, and it is going to limit the alternative signals like in power supplies, in electrotherapy equipment, electrotherapy department, and it also used in the to avoid the alternative signals in the fluorescent lamps. So first, in this filtering and smoothing, what will happen is from the DC output there will be a alternative current fluctuation. That filter, that choke coil, the choke coil is going to filter this unnecessary noise and ripple from the direct current output, and it is going to allow the direct current to pass on easily throughout the circuit. And then in fluorescent lamp, that is it is a higher frequency. In this fluorescent lamp contain the higher frequency. In this fluorescent lamp, what is the role of a choke is, first choke, it is going to start and limits the current, and then it produces the high voltage. So due to this high voltage, it is going to ionize the gas and it products a current for further burning that lamp. So this is what the role of chokes. So chokes is nothing but it is going to oppose the alternating current and it is going to allow the direct current based on the principle of self-induction and Lenz's law. Okay, what is the principle of self-induction and Lenz's law? So it is nothing but, that is when the alternating current goes through the coil, what will happen is there will be a production of the self-induced EMF, that is electromotive force. So that electromotive force is going to oppose the change in current because the alternating current is going to go in a reverse direction. So this self-induced EMF, it is going to work on, it is going to resist that flow of change of current. This is the role for the chokes based on the principle of self-induction and Lenz's law. So what are the function of choke coils? So it is going to, again it is going to control the alternative current. It is also helpful in moving the direct current with the minimal power loss. So in alternative current, what will happen? It conduct the high inductive reactance, high resistance. So what will happen is it is going to be limit this, it block the alternating current. This choke is going to block the alternative current, and in direct current it is going to allow the smooth transition throughout the coil. And then what happen? While alternating current, there will be a minimal power loss only, there won't be any wastage of any energy. Yes, what are the uses of chokes? So it is going to be used in the fluorescent lamp to start and limit the current, and is going to use in the power supply, that is to improve the power factor of the inductive loads, and it is going to be used in for filtering, that is in direct output. It is going to be filter the alternative current, noise and ripple, and for smoothing it is going to allow the smooth direct current flow, and it is also used for the protection. Protection, like if there is any flow of change in current, it is going to protect the choke is going to protect the circuit, and also it is used in the physiotherapy equipment. Physiotherapy equipment, like it is going to helpful in the current stability and frequency control in devices, mainly on the interferential therapy and shortwave diathermy. Next, we'll move on to the topic action potential. Okay, before we move on the topic, let me tell you a definition of the action potential. So action potential is nothing but there is a change in the potential difference across the cell membrane, particularly excitable cells like neurons and muscle fibers. So neurons, it was for the nerve impulses, and muscles, it is for the muscular contractions. So this is what the definition of the action potential. So action potential is nothing but there will be a change in the potential difference across the cell membrane, particularly the excitable cells like neurons and muscles. So neurons is essential for the nerve impulses, and muscles for the muscular contraction. Okay. This phenomenon is based off the ion movement and voltage gated channels. So this action potential is going to work on the physiological phenomenon by ion movement and voltage gated channels. So this action potential is worked on the three properties. So one is electrostatics, ion movement and electrical circuits. So what will happen is, if you are giving a stimulus, what will happen if that stimulus reaches the threshold value, then what will happen? The action potential will be fired. So once the action potential is fired, what will happen? There will be a spike in the voltage, it will be travel along the cell. Then we will see about the detailed action potential. Yes, it is a properties of the action potential. So first one is electrostatics and electrical circuit and resistance, diffusion and current law, and voltage and current. So first we will discuss about the electrostatics. Yes, see, action potential is nothing but the changes in the potential difference across the cell membrane, particularly neurons and muscles. Neurons for nerve impulses and muscle is for muscular contraction. So it is the phenomenon of ion movement and voltage gated channels, and then it is used on the properties of electrostatics, ion movement and current stability. And then last one is, if a stimulus reaches a threshold value, the action potential will be fired. Action potential fired is a sense in that that means is it is going to transmit the impulses along the axons. So once it is fired, what will happen? There is a spike of the voltage, so that it travels along the axons. Then we will move on to the properties of the action potential. So first one is electrostatics. So in this property, what is going to happen is, there will be a separation of positive and negative charge inside and outside of the cell. So this will be happening in the electrostatics. And then in electrical circuit and resistance, what will happen is, the cell membrane, that is going to act as an insulator, that is going to be a resistance to the ions. And then this gated channels, sodium and potassium gated channels, is going to be a switches in the sense it is going to open and close. Why it is want to open and close in the sense? Because only if it open and close, there will be a change in the resistance. Only there will be a change in the resistance, there will be electrical current will be produced. So this is what the electrical current and resistance. And then diffusion and ion flow. Okay, what is a diffusion and ion flow? So because this action potential is worked on the principle of the diffusion and the ion flow. Diffusion, it is a flow of ions. That flow of ions causes the change in the charge. Okay, so what are the ions? Sodium and potassium ions. So this ion going to change the positive and negative charge. So this is what the diffusion. This action potential will be worked on the properties of the diffusion. And also current flow, that is ion flow. Ion flow is nothing but if the ion moves, that will carry the charges. That time what happened? The current will be flowing. So once current is flowing, the action potential will be fired, that is it will transmit the impulses. So that is what between the diffusion and the current flow. So diffusion is nothing but there is a flow of ions causes the charges, and that is called the diffusion. And this current flow is the, when the flow of ion is going, it will carry the charges. So that is what difference between the diffusion and the current flow, which is worked on the principle of the action potential. And last one is voltage and current. Okay, what is voltage and current in this action potential is action. Let me know the difference. Let you discuss about the difference between the action and potential. So action is nothing but change in the voltage. Potential is that the charge will be built up. So that is what the action potential. So action is nothing but the changes in voltage. Potential is the charges that is built up. So whenever there is a change in the voltage, what will happen is there will be a production of ion flow. There is a production of the electrical current. So that voltage is going to push the ion flow, then will creating a electrical current. So this is what the voltage and the current. So these are the four properties of the action potential. So first one will be the electrostatics, that is going to separate the positive and negative charge inside and outside of the cell, and second one is electrical circuit and resistance. In this, what will happen, the cell membrane is going to act as a resistant, that is the ion movement is going to act as a resistant. So the voltage gated channels going to be switches to open and close. Why? Because only this voltage gated channels is going to change that resistance. It's going to change the resistance, only then the electrical current will be produced. And third one is diffusion and current flow. So diffusion is the flow of ion causes a change in charge, and current flow, while the ion is moving, it will carry the charges. So that will create a current flow, and then the action potential will be fired. So this is what the principal of, properties of the action potential, that is diffusion and the current flow. And last property is voltage and current. Voltage and current is nothing but, in the name action potential, the action means change in the voltage, that is voltage, and then potential means the charges will be built up. So whenever there is a change in the voltage, what will happen is the electrical current will be producing that this voltage will be pushing the ion to flow throughout the pump. Next, stages of action potential. So first one is resting stage, second is depolarization, third one is repolarization, fourth one is hyperpolarization, and last one is return to resting state. In resting state, what will happen? The cell, it will be inside the cell, it will maintain a negative charge. Okay, the cell membrane inside is going to carry a negative charge, and then there are two ions acting on this action potential. One is sodium, another one is potassium. So this sodium, it is going to be outside the cell, potassium, it is going to be inside the cell. So in a resting state, a cell membrane, it contains a negative charge inside, and the two ions, the sodium ions, it is going to be in outside, and potassium ion, it is going to be inside. So this is what the resting state. Next is depolarization. What will happen in depolarization is, in depolarization what will happen, the sodium gated channels that will open up. As soon as it is open up, the sodium ions will be rushed into the cell. So after the sodium ions rush into the cell, the internal negative charge will convert into a positive charge. So that will happen in the depolarization. In repolarization, what will happen is, the sodium channel will be closed, the potassium channels will be open. This potassium channels, this potassium ions, what is it going to do is, this potassium ion going to exit, it will going to exit the sodium ions. So the inside will become again negative. So in hyperpolarization, what will happen is, because of these process, already a cell membrane inside, it contains a negative charge. So due to this overlapping of sodium and potassium, it will become more of negative. That is in the hyperpolarization state. And last, in return to resting state, what will happen? The ion going to pump. So due to this ion pump, it will restore the normal negative charge. So this is what the stages of action potential. So the first one is resting state, next one is depolarization, third one is repolarization, fourth one is hyperpolarization, and then last one is returning to the resting state. Resting state, inside the cell, it is a negative charge, and there are two ions going to acting on it. One is sodium, another is potassium. In second stage, what will happen? The sodium channels, it is going to open, so sodium ions going to rush in. So it will make the inside the negative cell as positive cell, and then in the repolarization, what will happen? The sodium going to close and the potassium going to open. This potassium, what will happen? It is going to push off the stored sodium, and then inside already it becomes a positive. So again it is going to be a negative. So in hyperpolarization, what will happen? Because of these changes of ions, flow of ions, sodium, potassium, this will become more of negative inside. And then finally in the normal ion pump, the electrical flow will make the inside a cell as normal negative charge. So next move on to the topic, resting membrane potential. So when the cell is at rest, there will be a potential difference across a cell membrane. So in this resting membrane potential, there will be activity of ions, that is sodium and potassium ions, and voltage gated channels. Okay, and then what will happen in this activity? What are the activities going to happen is, as I already discussed in the action potential, the sodium channel is going to open, sodium going to rush in, as soon as the entry of the potassium, this potassium is going to pull off the sodium. So this is what the process. While this process, what will happen is, when the potassium in the 2 potassium is getting entry, the 3 sodiums will be pushed off. So this is what will be happening in the resting membrane potential, using the help of the active transport like ATP energy to fuel this process. So this is what happening in the resting membrane potential. These are the activity happening in the resting membrane potential. Yes. How would this maintaining? Okay. So first one is ion concentration gradients. So in the cell, what will happen is, outside there will be a higher concentration of sodium, chloride and calcium. Inside there will be a higher concentration of the potassium. Okay. So this is what will be happening in the ion concentration gradients. So outside the cell there will be higher of the sodium, chloride and calcium. Inside is of potassium. In the selective permeability, what will happen is, the cell will be contains the more number of protein channels, but it will be permeable to the particular ions only. So this cell, there are so much of potential, sodium, calcium and potassium, so much of things. So in this resting membrane potential will be, this cell membrane will be more permeable to the potassium ions only. That is why what will happen is, as soon as the entry of the potassium, this potassium is going to exist of the sodium ions. So inside the positive charge, it is going to become a normal negative charge. Okay, this is what happening in the potassium peak. And then in sodium potassium pump, what will happen is, this 3 sodium is going to pull off and 2 potassium is going to getting in. So while this process is happening with the help of the ATP molecules, that is the active transport of the ATP to fuel this process. So this process will makes the inside of the cell normal negative. So this is what the maintenance of the resting membrane potential. So in this ion gradients, what will happen is, outside will be of the sodium, calcium and the sodium, chloride and the calcium, and the inside of the potassium. So in this active permeability, what will happen is, the cell will be containing more number of protein channels, but it will be permeable to a particular ion only. So that particular ion is called as the potassium. So this is permeable to the potassium. So potassium is what is doing when it is getting entry, when it is giving entry, it will be pushing off that sodium. As soon as the pushing of the sodium, the inside will become more of negative. Usually a cell internally it will maintain a negative charge, but due to this process it become a more negative. So this sodium potassium pump, it is going to make the inner cell as normal negative energy. So this is what the activity of a resting membrane potential. And then, so why this resting membrane potential is very much important? It is very much important for the communication, signal transmission and for the other functions. What is the communication baseline for the communication is, it is going to communicate with the nerves and the muscle. What is going to communicate? It is going to communicate with the nerves and muscle to get ready for the transmitting the signals. Okay. So what are the things it is going to transmit is nerve impulses and the muscular contraction. So it is going to carry the impulses along the axons with the help of the resting membrane potential. So resting membrane potential is working based on the principle of based on the help of the neurons and the nerves, that is nerves and the muscles. For the nerve impulses and for the muscular contraction, and is going to transmit the impulses toward along the axon. This membrane action potential is going to take out the responses along the axons, and for other functions it is going to be used for the wound healing, and also it is used for the cancer progression. Next we will move on to the topic propagation of action potential. Okay, what is the propagation of action potential? Okay, now I will tell you. When the nerve impulses travel along the axons, what will happen? There will be a depolarization of wave. Okay, when the nerve impulses travel along the axon, there will be a depolarization of wave. So that time what will happen? That time the action potential has to be generated. So this is a normal thing. It is a basic thing. You have to know, when the nerve impulses travel along the axons, there will be a depolarization of the wave. That time the action potential has to be generated. So this will happen in either of two ways. One is with the help of unmyelinated axons, another one is myelinated axons. So in unmyelinated axon is a continuous wave. Myelinated axon is a jump of one node to another node. Okay, so propagation of action potential is nothing but it carrying a nerve impulses along the axons. There will be a depolarization of wave. That time the action potential is generated. So that action potential is generated it will be in either of two ways, either by a unmyelinated axon, another by a myelinated axon. So in unmyelinated axon, the process will be of a continuous wave, and in myelinated axon it will be of jumping process, jumping from one node to another node. So this is for the outline of the propagation of the action potential. Yes. Now we will discuss about the unmyelinated axons. So unmyelinated axon is how it is working is like, when you are giving a local current to a cell membrane, that cell membrane, this is a cell membrane, you are giving a local current. So this cell membrane, what will happen is, this cell membrane is going to ask the adjacent membrane to reach the threshold value. So this adjacent cell membrane, when it reaches the threshold value, there will be a firing of the action potential. Okay, so in unmyelinated axon, what will happen is, when the current, when you are giving a current to a cell membrane, this is a cell membrane. Imagine this is a cell membrane. You are giving a current. What will happen? This cell membrane is going to do is it is going to ask the adjacent membrane to reach the threshold value. So once it reaches the threshold value, what will happen is there will be a firing of the action potential. Okay, so this is what the unmyelinated axons. Okay, so in this I want to say you something. So the current is passing, this membrane is going to make the adjacent membrane to reach out the threshold. So that time the action potential is fired, and once the action potential is fired, it will not do a work anymore, because once it is fired, it cannot fire again immediately, because there is a refractory period. That is, refractory period is nothing but there is a time period for this action potential to be firing. Okay, so once it is fired, it will not refire again. So once it transmits the impulses, it will not transmit again. So this is what the refractory period. Why? Because this action potential will go only in one direction only. So that is the difference for the action potential refractory period. Again I will say you, this unmyelinated axon is nothing but the current is passing through the cell membrane. That time the cell membrane will make the adjacent membrane to reach the threshold value. So that when it reaches the threshold value, there will be a action potential firing. So once the action potential is fired, it will not refire again. Okay, so that is due to the refractory period. Why? Because this action potential is going to travel only in one direction. So this is what will happening in the unmyelinated axons, that is the continuous way. In myelinated axons, what will happen is, it is a jumping process from one node to another. So in this also same, the electrical signals, it is going to be carry. When it is carrying and coming, what will happen is, it is going to resist by the myelin sheath. So axon is covering by the myelin sheath. So when the impulses is carrying, this myelin sheath is going to resist. How long it is going to resist? Until this impulse is going to reach the next unmyelinated axon, next unmyelinated node. It is going to resist. The myelin is going to resist. That is, the electrical impulses is carrying. It is coming quickly, and it is resisted by the myelin sheath. How long it is going to resist this? Until this impulses reaches the unmyelinated nodes, it is going to be get resisted. Okay, so at this stage, what has to be happen is, the impulses is getting lagged, but the impulses has to travel along the axon. So for that, what will happen is, a new action potential is generated. Okay, for that the new action potential is generated. Only then the new action potential is generated, the impulses will be travel along the axon. So only then the impulses will be travel along the axons. Otherwise the impulsion will be, it is going to get lag in that particular place itself. That is why the generation of the action potential is occurring. This is what the myelinated axons. And then what are the factors affecting the propagation speed? One is myelination, axon diameter, and then temperature. So in myelination, what will happen is, the myelinated axon will be conducting the impulses much faster than the unmyelinated axons. And then in axon's diameter, what will happen is, the axon will be of thick. Okay, so the current flowing through is very easily it is flowing because of the thick axon diameter. And last one is temperature. If there is a higher temperature, the ion movements will be moving very faster for this propagation of action potential. So this is what the discussion about the factors which are affecting the action potential, that is factors affecting the propagation of the speed. So today we discussed about the chokes, action potential, and resting membrane potential. So choke, it is going to oppose the alternative current, and it is going to allow the DC current to helpful in the circuit. And then action potential is, that is the change in the potential difference across the cell membrane. Okay, particularly the nerves and the muscle. And then resting membrane potential is, when cell is at rest, it is going to create a potential difference across the cell membrane. And then propagation we have seen that when there is a current is passing, there will be adjacent membrane to reach the threshold value. That time action potential is generated. So it is of two ways. One is myelinated and the one is unmyelinated. And then we have discussed about the factors affecting propagation speed. That is, myelinated is conducting much faster than the unmyelinated, and it also factors depending on axon diameter. That is, when there is a thick axon diameter, it is going to speed up the electrical current. And then last one is temperature. If there is a higher temperature, the speed of the ion movement will be very fast. So this is what about the today's discussion. Thank you.